Welcome back to solving systems of linear equation. Well, we want to take a look at solving special systems. And our objective here is just to classify these systems of linear equation and determine the number of solutions. What do we talk about when we talk about number of solutions? Well, we actually looked at when we were graphing equations. We said if we have a line and an equation runs here and it runs here, then it has a point of intersection. And when there's a point of intersection, we're talking about there's exactly one and only one solution to this particular system. So when there's only one solution to a system, it is called consistent. Consistent. Okay? It is called consistent. So when there's just one solution, when they intersect at a point of intersection, we say that this system is consistent. Okay, so now we want to take a look at when two lines in a system do not intersect. What are we talking about? So let's just go ahead and quickly take care of this and let you see exactly what I'm talking about. So if we have a coordinate plane and we have a line that's going here and another line is here, okay, these lines do not intersect. Okay, so that means if the two equations do not intersect, there is no ordered pair that's going to satisfy both equations. So in plain words, there is no solution. Okay, and if a system has no solution, we say that it is inconsistent. Okay, it is an inconsistent system. No solutions whatsoever. Okay, just keep that in mind as we work through this one problem here, and everybody should be okay. Okay, so let's go ahead and use a different color. So when we're dealing with these systems with no solutions, we have a couple of methods that we want to do. Method one says you want to compare the slope and the y-intercept. You want to compare the slope and the y-intercept. So how can we compare the slope and the y-intercept? Well, we must write both equations in slope-intercept form. We have to write them both in slope-intercept form. So we have the equation here. Y is equal to a negative 2x plus 5. Okay, and then we have the equation 2x plus y is equal to 1. Okay, this equation is already in slope-intercept form. Y is equal to a negative 2x plus 5. Little work to do there. But with this particular equation, it is 2x plus y, so we can visually see that what we need to do here is we need to get y by itself, is we need to subtract 2x from both sides. Okay, so subtracting 2x from both sides will give us y is equal to a negative 2x plus the 1. Okay, so now we have them in slope-intercept form. So what do we see? What do we see? Think back to when we were talking about parallel and perpendicular lines, what do we see? They actually have the same slope. So if two lines have the same slope, then they are parallel, which means this system has no solution, so it is an inconsistent because the lines are parallel. Okay, so now that's the first method. Pretty simple, isn't it? Okay, so let's take a look at method 2. Method 2 says we need to solve the system algebraically. Okay, so what we mean by algebraically, we talk about substitution, we're talking about elimination. Okay, so which one will we be able to use here? Well, it all depends. So let's go back again and look at the original. We'll want to look at the original equation. So we have y is equal to a negative 2x plus 5, and we also have the equation 2x plus y is equal to 1. Okay, so in order for us to be successful here, let's look at it. What do we say when we talk about elimination? Or what do we say when we talk about substitution? If you notice, the first equation is already solved for y. So all we need to do is substitute a negative 2x plus 5 for y here and solve. So let's just go ahead and do that. So here we will have 2x plus, and y is a negative 2x plus 5. Okay, and that's going to equal to 1. So we're using this equation here. Okay, so now let's just go right ahead on and deal with our like terms. So anyway, we have this plus a negative, so let's go ahead and write this out. It's 2x minus 2x plus 5 is equal to 1. Okay, well, 2x from 2x will give us 0 plus 5 is equal to 1, and 5 is not equal to 1. Okay, so we can see that this equation actually is false, and it's a contradiction. False equation, and it's also a contradiction. So what's that telling us? That is telling us that there is no solution. Again, what we found out up here, that there is no solution. So again, we've shown you using our slope and y-intercept, and we also have shown you here algebraically that it is a contradiction. So that means that it is parallel. So again, you can check this pretty simple. All you got to do is go ahead and create a graph. And if you create a graph, see, can we have time to do that? We may have a few minutes. So let's see, can we create a graph right quick and see what it'll look like. Okay. Okay, so let's go right ahead, and we're just looking really at 5 and looking at 5 and 1. So it's going to be all negative, but we'll go ahead and put some up here anyway. 1, 2, 3, 4, 5, and then here's where we're going to go. 1, 2, 3, 4, 5. Put some more up here. Okay, so our first equation tells us that And we're graphing the way we normally do. We have a plus 5, so our 0 and 5, so that's going to be 1, 2, 3, 4, 5. That's our first point. And our second point will be going down 1, 2, and over 1. That's our second point. So we can just go right ahead and put this line. So we're going to go down. Okay, so now we are looking at, let's change this to blue. Well, I'll change it to a different color here so we don't contrast. Get to this purple. Okay, so we're looking at 1. So our first point. First point is 1. Okay. I have some issues this time of day. All right, so we have 1, and then again we're going down 2, 1, 2, and over 1. Okay, that's our second point, and then let's just go ahead and put a line to it. Okay. So with this one, this is the way our line is going. And as you can see, they are parallel. So we can just go ahead and understand that we checked, we've looked at them graphically, and actually via the graph we could see that the lines are inconsistent because they do not intersect. But these are just the ways when we want to look at this special type of system to determine how many or the number of solution per system. Okay. Talk to you soon.